Okay, so here we are at Natowich Field, and our theme for today is going to be uh, the emptiness of an atom. So yesterday our focus was how small atoms are, or the size of atoms. We tend to think of them as small. Hey, you. And today, the idea that I want you to understand is that atoms are mostly made up of empty space. So we're going to build, or actually I built most of it already. We have a model of a carbon atom out here at Natowich Field, and the parts of our atom that we're going to talk about specifically today are the nucleus and the electron blur, I'm going to call it. The nucleus of our carbon atom is this marble, and I'm going to put it down right here. And so that's the nucleus of a carbon atom. Carbon is number 6, which means it has 6 protons and 6 electrons. The 6 protons are in that nucleus. Okay, so we have a nucleus, and if that is the center of the atom, then where's the rest of the atom? And that's something that's pretty amazing. And if you look down here, let's see, I don't know if you can quite make it out, but there are 2 patches of snow. There are actually 3 patches of snow, but only 2 of them are part of our model. That first one is very close to the middle of the field, and that is where the nearest electrons are. And then the patch beyond that is where the more distant electrons are. So what we've got is we've got a nucleus with protons and an electron blur. And there's 6 protons in the nucleus, as I've said, and there are 6 electrons in the electron blur of a carbon atom. And so the electron blur, electrons are often referred to as particles by science teachers. That's not really true. You know, they do have a particle nature to them, and it's most simple if we think about them as particles. And so when I talk about them, it will be primarily as particles. But for some of you kids, we're going to grow, Eben and Genevieve and Evie, you guys are who have the capacity to play with sharp pencils than I ever played with. You need to start hearing that they're not just a particle, they're part particle, part wave, and that duality isn't really going to matter in 8th grade science, but I don't want to be someone who told you that an electron is a particle. So anyhow, where are they? They're about that far away right now, but they're not going to be there for long. Okay, so what we know about electrons is that they tend to exist in pairs, and they tend to move really, really fast, like thousands of miles a second. We infer that they move because they are in one place and then another place. We don't actually see them move, but that's how we infer the speed and the motion, is that they end up, being in a different place very quickly. So that's beyond the scope of what I want to talk about today. If you missed a lot of that, you should understand that there's a proton, and that's the marble with 6 protons in it, and that's the center of our model right now. And those first 2 electrons, those represent a pair of electrons that could be anywhere in a grand sphere about that distance, which on this scale is about 60 meters from here, and they could be 60 meters above, 60 meters above that way, 60 meters below that way. But if you can imagine like a sphere, and that's why when we look at sort of sketches of atoms, they tend to be kind of blurry and show things moving, and those are the electrons, but they tend to be, electrons tend to be at certain finite distances from or certain specific distances from the nucleus. And that first pair, right, so that's 2 of the 6 electrons are at that first distance, which we would call the first energy level. The electrons beyond that, there's another pair, if you can see it, I'm not sure what you can make out with this camera, but that second clump of snow, which is about another 50 meters beyond this first clump, that second pair of electrons is on the second energy level, so they must have more energy, and that sphere is simply bigger. So they could be 110 meters above us, or 110 meters below us, or 110 meters over that way. But it's another, I'm sorry, I'm having trouble moving my arm. I'm only a couple of days out of surgery. So we have the nucleus, and then we have these energy levels. And carbon has two possible energy levels. The first one with 2 electrons, and the second one with 4 electrons. And again, that's more detail than you need, but I forgot to tell you about the relative sizes of the protons and the electrons. I did tell you that there's 6 protons in this scale model there's 6 protons in that nucleus. And I've told you that there are 6 electrons, but I didn't tell you they're the size of sort of the tiniest grains of sand that we could have picked up at Race Point Beach. And so they're tiny, and they're really far away. And so that's what you're made of. Almost nothing. Okay, and so you can ask yourself, how can that be? You know, I go like this, and with that scale, you would think that your parts of your body would just pass right through each other, and if it was just the particles involved, that would happen. But there are also lots of forces, and that gets more complicated, and we will talk about those. But not today. So today, the main idea is that, and I'll give you something to read about this. I realize I'm talking kind of fast, and it's starting to get a little bit cold out here. You probably can't see those little clumps of snow, and you definitely can't see the 2 grains of sand at representing the electrons in the first energy level, and you can't see the next pair because electrons again tend to exist in pairs. And I'm hoping that you can imagine that they would be anywhere in those spheres. So, I don't know. I fear I wasn't very clear about all of that, but that's the idea, is that today I'm hoping you'll take away an understanding that you are mostly made of nothing, because you are made of atoms, and atoms are mostly made of empty space. That doesn't mean you're not important, and it does not mean you're not loved. Okay, thank you.